Last video for now, we're going to do reduction of nitriles. That way, if you've attended SI and you've watched the videos, you should be all the way up until aldols for the most part. I haven't gotten much into cyanohydrins, weak nucleophilic addition. Those are pretty short, and I think I'm not going to bother with much. Okay. Anyway, nitrile reduction can either be under acidic or basic conditions. Just like when we made hemiacetals under acidic and basic conditions, the reaction is pretty much the same except at the beginning. We protonate at the beginning and acidic, we just attack straight away because we have a good nucleophile. So remember, acidic is improving our electrophile, basic is improving our nucleophile. Okay. Let's go ahead and start out here with, remember, reduction. So we want as many hydrogen bonds as we can. That should tell us, in this case, going from a nitrile, if I were to reduce a nitrile as much as I could, I would get an amine. And if I wanted to oxidize an amine as much as I could, I would get a nitrile. I'm increasing the number of hydrogen bonds to my substituent. In this case, nitrile function group is nitrogen. Here, nitrogen carbon double bond or triple bond. We're going to reduce that and we're going to get hydrogens on this thing. Acidic conditions, think of pi bonds the same as, or triple bonds the same as like carbonyl groups, okay? This carbon here is positive, as a partial positive for the same reason it would with a carbonyl. So we're going to treat it the same. I'm under acidic conditions. To activate, I'm going to activate this site here. Lone pair of nitrogen will protonate first. Just like when we're under any acidic conditions, really, with a carbonyl, or in this case, a nitrile. Now we're activated. And I get water as a result. I have an activated electrophile there, and I have a nucleophile. On a nitrogen. Notice I'm already down to a carbon-nitrogen double bond, so I'm getting closer. This makes sense so far, getting reduced. At the end, I should only have a single bond, so good so far. There's our double bond, the nitrogen. It has a hydrogen on it. And at this site, I attached our, oh, I wrote that wrong. This needs to be, my bad. That should be water. I took one proton off of it, that should be water. We're under acidic conditions. And here we attached water. I attach water there. I have a charge. That's because of a proton excess. So I go ahead and take that proton off. You see water here, like, oh, what if water leaves? If water leaves, I'm reforming the triple bond. Water leaves, that's the opposite of what we just did. So a good sign not to do that. Instead, we're just going to go ahead and take a proton off. There. And we'll go down here with it. Okay. This is where we get funky. Strange, again, it has to be memorization. There's a lot to memorize for this assessment. So I don't really know a good rule for this. Yep, it's going to be memorization. What might help with this, we started with H3O plus, and we turned it into water. We turned water, well, we made water attack, okay? Made water attack. The deprotonate, we used water, and we made H3O plus again. So it's kind of a back and forth thing we got going. What is a way we can get closer to an amine here? Either take bonds away from here or add hydrogens onto nitrogen. I have H3O plus. I'm going to take the lone pair of nitrogen and I'm going to protonate it. H3O plus. I'll just protonate it. Right? Yep. All right. So weird reaction in the OH group. Okay, we're almost done. We're going to now take, we made water, right? So we went from H3O plus to water to H3O plus, now to water again. So that should tell us we're going to take a proton off of something. Here we're going to deprotonate our alcohol group. This bond will form a oxygen. On to nitrogen. Are there 3 arrows there? There are 3 arrows. Okay, so we have deprotonate our oxygen, our alcohol group. This forms the double bond with carbon, and that allows us then to make a single bond with nitrogen. And we also eliminate that charge. These 2 steps, tough. Just have to memorize them. Nitrogen is going to protonate first, and then once we're there, it's got to go alcohol, carbon, nitrogen. There's our primary amine. It's cool. And then our final product. Yep. And we're done. So we reduced our nitrile all the way down into a carbon-nitrogen single bond. There. Okay? That one's tough. Watch it again, try it on your own, and then try it on your own, maybe make your own problem, or test someone else on it. We're not going to do another one because that's what the point of the videos are for. You can rewind them. We're going to do something very similar though, which might help, and we're going to do the same thing under basic conditions. I'm going to start up here with it. Basic conditions, I'm not going to activate anything off the start. I'm just going to go straight nucleophilic attack. Who has electrons, who wants them, and boom, we're already down to 2 bonds on carbon and nitrogen. And nitrogen charge. Protonate nitrogen. And we're under basic conditions, so I'm going to use water to protonate. Sweet. And I think we can work the same way as we did before here. Yep, we protonated there. Alcohol down. Ooh, it's a little bit backwards. It's just a little bit backwards here. So our first step is going to actually be what was our second step before and in our acid catalysis, or acid reduction. And basic reduction is when we have this long step here and we deprotonate our alcohol. First. And then where are we going? Remember, up to carbon and on to nitrogen. Sweet. And then we'll get water. What am I going to use to protonate? I'm going to use water. The water I made, really. Could do that. And I'll be left with the same product as before. So, if you notice, the steps in our basic mechanism, these two switched on us. Okay? These two down here switched. When we did acid reduction, we protonated our nitrogen first, and then we had our alcohol carbon on a nitrogen. When it's basic, we do the opposite. We just flip it. We go alcohol, carbon, nitrogen, and then we protonate our nitrogen after that. It's weird, it's funky. I don't know especially why that is right now. It's something that has to be memorized. It will be likely be memorized. I would memorize it. Okay. I would say it's basic. I'm under basic conditions. I need OH minus. I'm going to attack my OH group first under basic. And when I'm acidic, there's a lot of protons. My first step is going to be protonation. If I'm under acidic conditions with the nitrile, when I get to this point, it should be protonation first if I'm acidic. If I'm basic, it needs to be, I need to be taking, maybe that's why it's like that. I need to be doing a deprotonation, basic deprotonation first, acidic protonation first, in these two steps here. Okay, it's a lot, but you have time. Have a full another 5 days, that's 120 hours to study OChem. Maybe sleep a bit, but mostly OChem.